Good morning. This webinar is being recorded, and by joining, you agreed to be recorded. Welcome. My name is Ashley Lester, and I am a public participation specialist with the Department of Toxic Substances Control, which we will refer to as DTSC throughout this workshop. Thank you for taking the time to join us today. The purpose of today's workshop is to present our proposal to add para-Phenylenediamine PPD derivatives to DTSC's candidate chemicals list, and to hear your feedback. Our workshop is scheduled to go until 12 p.m. or until the end of the Q&A public comment portion, whichever is sooner. I will be facilitating today's workshop together with Logan Hayes, environmental scientist in our Safer Consumer Products program. Next slide, please. You are in a view and listen only role. Today, we will be taking questions through the Q&A feature. Please click on the Q&A button on the toolbar at the bottom of your screen to send us your questions. You may submit your questions and/or comments at any point throughout this webinar, and we will respond during the Q&A session at the end of the presentation. You may submit as many questions as you want. However, we do request that you submit one question at a time so that we can respond to them adequately. We will do our best to respond to the questions in the order they are received. Please note that we will not be taking questions by the chat function. For those joining by phone, please press *9 to raise your hand to let us know you have a question. When it is your turn, you will be called on and prompted to unmute yourself. If you prefer, you can also send your questions and/or comments to saferconsumerproducts@dtsc.ca.gov, and we will respond after the workshop. Lastly, please know that we are hosting this webinar from different locations and request that you bear with us if there are any time lags or any other technical difficulties. We sincerely appreciate your patience, understanding, and cooperation in making this a successful workshop. Next slide, please. Today's workshop will be presented by staff from Safer Consumer Products Program. The agenda is as follows. Andre Algazi, Chemical and Product Evaluation Branch Chief, will give the opening remarks, followed by a presentation from Logan Hayes, environmental scientist, and Lynn Nakayama Wong, staff toxicologist. Then we will have time for a Q&A public comment session. We will then conclude with a closing statement from Carl Palmer, Deputy Director. I would now like to welcome Andre Algazi to give his opening remarks.
Good morning, everybody, and thank you, Ashley. I would like to welcome you all to our public workshop on 6-PPD derivatives. If you've been engaged with the Safer Consumer Products Program over the years, you know that we have a lot of public workshops in our process of developing regulatory proposals, and today's no exception. With the publication of the Tian et al. Paper in 2021, it became clear that 6-PPD was the transformation product 6-PPD quinone was the cause of mass cyanide die-offs in the Pacific Northwest, and that was a significant adverse impact. We worked on regulations to add 6-PPD in motor vehicle tires to our priority product list, and that regulation took effect on October 1st. So today, we're here to talk about a related class of chemicals, 6-PPD derivatives, and the reason for our interest and focus on these chemicals is the fact that like 6-PPD, they are reactive, they are potential alternatives to 6-PPD as anti-ozonants in tires, and we're concerned that if tire manufacturers consider and evaluate other PPD derivatives as potential replacements for 6-PPD, that they do a thorough alternatives analysis as laid out in our framework regulations. So again, our staff have put together an excellent technical background document that has been posted on the workshop page. So hopefully you've had a chance to look at it. If not, you can look at it after the workshop. And we're going to be hearing from our excellent staff who will be laying out their findings and the rationale for this proposal, which would ultimately add 6 PPD derivatives to our candidate chemicals list as a class. This is a new type of regulation for us. We've always had the authority under our framework regulations to add candidate chemicals to the list. But up to now, we haven't taken advantage of that authority. All of the candidate chemicals on our list currently are there because they are on one of the 23 authoritative lists that is incorporated by reference from our framework regulations. So thank you again for attending. We want to hear from you. We want to hear your comments and suggestions. If we've got something that's unclear or you think we've missed the mark in some way. And that's really the reason for having these workshops, is to get it right so that when we start rulemaking, we're confident that we're pretty close to the rationale and the language that we want to use to go forward. So I just encourage you to listen and comment. And we have excellent staff who will be presenting to you today, starting with Logan Hayes. So I'm not sure if Ashley is going to be introducing Logan or if he's just taking it over, but thank you again for being here. And we look forward to your comments.
Thank you, Ashley. Thank you, Andre. Good morning, everybody. My name is Logan Hayes. I am an environmental scientist with the Safer Consumer Products, or SCP program in DTSC. I'm also a member of the team proposing to add para-Phenylenediamine derivatives, shortened to PPD derivatives, to the candidate chemicals list. And we thank you for joining us today to learn more about this class of chemicals and why we are proposing this action. Shown here is a sneak peek into today's presentation. First, we will introduce the Safer Consumer Products program and then introduce the topic of PPD derivatives. Next, we will review evidence indicating the potential for exposures to PPD derivatives with example highlights for water and sediment. And finally, we will review the hazard traits associated with PPD derivatives. We will wrap up today's presentation with an opportunity for you to ask questions and provide comments about this proposal. We'll start with a high-level overview of the SCP program. SCP's programmatic mission is to advance the design, development, and use of products that are chemically safer for people and the environment. And we work to do this through a few goals that include reducing hazardous chemicals in consumer products and increasing the adoption of green chemistry principles and safer alternatives to chemicals of concern in consumer products. Next, we'll review the framework that shapes the work we do at SCP to achieve our mission and goals. The graphic you now see illustrates the 4-part SCP regulatory framework. This process starts with the candidate chemicals list that we manage by combining substances from 23 authoritative lists into one. As we will discuss in much greater detail today, SCP is also able to add chemicals to this list. We then select substances from this menu of candidate chemicals to propose product chemical combinations that may cause harm in the form of priority products. It's important to note that the listing of a priority product is generally the first time where our regulatory framework places regulatory requirements on the manufacturers of consumer products. Next, manufacturers complete alternatives analyses for the priority products, where they thoroughly evaluate the priority product and potential alternatives to determine if there is a safer product. Finally, SCP considers the alternatives chosen by manufacturers of priority products to select one or more regulatory responses that prioritizes the prevention or management of potential adverse impacts to human health and the environment. This 4-part process is a simplified summary of our primary mechanism for reducing the exposure to harmful chemicals in consumer products through the shepherding of product chemical combinations, through the priority product, alternatives analysis, and regulatory response phases. What this image doesn't show is the rigorous scientific analysis and stakeholder engagement mixed throughout that builds muscle on the backbone of this framework. This very workshop is a crucial step in our work where we present our research and solicit feedback from the public to help strengthen the actions we take to build a safer world. As described in the California Code of Regulations, SCP may add chemicals to the candidate chemicals list if they exhibit one or more hazard traits and/or environmental or toxicological endpoints by considering specific factors that are also listed in the California Code of Regulations. All of the specific factors that we are required to consider must show that 3 criteria are true of a chemical. First, that there are potential exposures to the chemical. Second, that there is potential for one or more of these exposures to contribute to or cause adverse impacts. And third, that we have considered the extent and quality of information that is available to substantiate the existence of those potential exposures and adverse impacts. If these 3 criteria have been met for a chemical, we may initiate the rulemaking process and propose to list it on the candidate chemicals list. Now that we've covered a high-level overview of the Safer Consumer Products Program with a highlight for how we may add chemicals to the candidate chemicals list, it's time we move on to an introduction of the PPD derivatives chemical class. We first became aware of PPD derivatives because of our research into 6-PPD and its presence in motor vehicle tires. 6-PPD is an anti-degradant used in virtually all tires and has recently raised significant global concern after mass die-offs of coho salmon were attributed to one of its transformation products, 6-PPD quinone. Because of this concern, we recently adopted regulations to list motor vehicle tires containing 6-PPD as a priority product, which became effective on October 1st of this year. While PPD and 6-PPD are currently on our candidate chemicals list, other PPD derivatives are not. PPD derivatives are small reactive molecules that are viewed as the most effective and currently available anti-ozonants for use in tires. Other PPD derivatives, however, also have concerning hazard traits. We will talk more about our proposed PPD derivative definition a little later. Other PPD derivatives have experimental data demonstrating aquatic toxicity of fish, invertebrates, and algae. As shown here, 6-PPD, PPD, and 4 other named PPD derivatives display very high toxicity to fish and invertebrates in experimental settings. This data led us to conclude that we should conduct further research into the safety of the greater class of chemicals. However, because PPD derivatives appear to be the most likely alternatives to motor vehicle tires containing 6-PPD, and they aren't candidate chemicals, we knew we would need to define a class based on their hazard characteristics to ensure that they are given the highest level of scrutiny in the alternatives analysis process. It's important to keep in mind that 6-PPD's toxic transformation product, 6-PPD quinone, is nearly 10,000 times more toxic than the criteria for very high aquatic toxicity. This means that PPD derivatives may still be a safer alternative to 6-PPD. The acute aquatic toxicity of these substances is not surprising because they are small reactive chemicals, and reactivity is one of the predictors for higher aquatic toxicity. The full names and structures of the PPD derivatives shown on this page and on others in this presentation are listed on pages 7 and 8 of the technical document that has been linked in the chat. Listing PPD derivatives as candidate chemicals is expected to create multiple positive impacts. Most importantly, we believe listing PPD derivatives will enhance the overall success of the priority product process for motor vehicle tires containing 6-PPD for 2 principal reasons captured by the first 2/3 of this slide. First, it would signal that PPD derivatives merit strong scrutiny if evaluated as potential alternatives in any alternatives analyses for motor vehicle tires containing 6-PPD. Next, it would give SCP greater authority and flexibility when imposing regulatory responses if tire manufacturers select another PPD derivative as a safer alternative to 6-PPD. Both of these impacts would help protect public health and the environment by ensuring that SCP can take measures to mitigate the trade-offs of substituting 6-PPD with another PPD derivative in motor vehicle tires. And finally, adding PPD derivatives to the kinetic chemicals list would allow SCP to consider regulating consumer products containing any member of the class of PPD derivatives as priority products if we find that there is a potential for exposures and significant or widespread adverse impacts. But we haven't yet started researching any product chemical combinations containing PPD derivatives besides, of course, motor vehicle tires containing 6-PPD. We would have that option in the future if we added this class of PPD derivatives to our kinetic chemicals list. And so now we're at the point where you might be asking, exactly how do we propose to define the class of PPD derivatives? Our proposed definition for PPD derivatives is multifaceted, but broadly speaking, PPD derivatives are substances with a PPD backbone that have carbon or singly bound nitrogens attached to the PPD nitrogens, in blue on the structure shown, with no substituents on the phenyl ring. The full class definition can be found on page 3 of the technical document that has been linked in the chat. But breaking this down piece by piece, PPD derivatives have one or two substituents on one or both PPD nitrogen atoms that you are again shown in blue on the structure you see. Next, the substituents on the PPD nitrogens can be nitrogen or carbon only. And our definition only includes substances with molecular weights equal to or less than 1,000 Daltons. In multi-component compounds, this only applies to the components that are PPD derivatives. There are also some important exclusions in our proposed PPD derivatives definition. First, our PPD derivatives definition excludes molecules with nitrogen-nitrogen double or nitrogen-nitrogen triple bonds at the PPD nitrogen atoms, again marked in blue. In addition, our definition does not permit substituents or modifications to the PPD phenyl ring at the 2, 3, 5, or 6 positions, as numbered on the PPD derivative parent structure shown here. And finally, we have excluded substances that contain quaternary amines. Molecules with quaternary amines, also called quaternary ammonium cations, are classified as quaternary ammonium compounds, or QACs. To build the class of PPD derivatives, we first identified the common features between the more studied PPD derivatives. More studied PPD derivatives are members of the class that have experimental and modeled data referenced throughout the technical document for this proposal. We used these common PPD derivative features to perform a substructure search in US EPA's Hazard Comparison Dashboard's search module, shortened to the HCD on the slide in front of you. We also considered principles of chemistry, specifically resonance theory, to integrate the effects of electron donating and electron withdrawing groups into a chemical class with the goal of primarily capturing highly reactive molecules. In addition, we used the Hazard Comparison Dashboard's ToxPrints module to remove QACs that have quaternary amines. The final output of these steps was a list of 1,849 PPD derivative substances. Because these databases are updated with new information, we don't expect this method to produce the exact same number of results today. Before adding chemicals to the kinetic chemicals list, we must first consider their potential for exposure. And one of the ways we can do this is by understanding their production and use. 8 PPD derivatives, shown here, are high production volume chemicals in the United States. High production volume chemicals are either manufactured or imported at quantities equal to or above 1 million pounds per year. These PPD derivatives have been used by various industries as anti-degradants, antioxidants, anti-ozonants, hair dyes, photographic processing aids, analytical chemistry reagents, standardized chemical allergens, gasoline additives, and more. And more than 100 PPD derivatives have also been listed in the US EPA's chemical product database since 2012, indicating their presence in consumer goods. The high production volume of some PPD derivatives and reported presence in products of even more are both indicators of potential exposure. Presence in the environment is another critical component of understanding a chemical's potential for exposure. While researching this chemical class, we have found literature describing the detection of 13 different PPD derivatives, along with multiple quinones, in nearly every major environmental medium. This includes water, sediment from inland rivers to the deep sea, particulate matter, dust, and roadside soils. While most of these monitoring data are from China, it is still indicative of their potential for detection in a large variety of environmental media. The important takeaway is that if PPD derivatives were to replace 6-PPD in tires, their worldwide use and emissions to the environment would increase. Water is our first environmental exposure highlight. Water is a noteworthy medium because of our concern for the potential aquatic toxicity of PPD derivatives, as has already been demonstrated by PPD and 6-PPD, among others. 7 PPD derivatives, as listed here, have been detected in runoff, river water, and wastewater. Runoff samples were collected from a small canal in Hong Kong that drains a dense traffic roadway shortly after rain events. Multiple PPD derivatives have also been detected in the surface waters of rivers in urban areas of China. And finally, wastewater samples measuring PPD derivatives have demonstrated the difference in concentrations between the influent and effluent waters, suggesting that wastewater treatment may not be an effective way of decontaminating water from these pollutants. The chemical structures on the left demonstrate the similarities between many common PPD derivatives. Sediment is the other environmental exposure we'd like to highlight. Specifically, a study completed in the Pearl River Delta of China, where sediment samples were collected from urban rivers, their estuary, the coast, and deep sea locations. All 8 PPD derivatives tested were detected in urban river, estuary, and coastal samples, whereas only one species was no longer detected in deep sea sediment samples. The total PPD derivative concentrations decreased with distance from urban rivers, demonstrating a statistically significant spatial trend that aligns with our understanding of PPD derivatives' presence in highly industrialized regions with high traffic volumes. The results of this study showed that PPD derivatives appear to persist long enough to survive long-distance travel to distant regions of the South China Sea. And now I'm going to pass the presentation over to Lynn Nakayama-Wong, staff toxicologist here at the Safer Consumer Products Program.
Thanks, Logan. In addition to exposure considerations just summarized by Logan, we're required to identify potential adverse impacts associated with our proposed class. We used reliable information to identify toxicological and environmental hazard traits of concern, again, by evaluating structurally similar chemicals to PPD. The SCP regulations allow us to consider information from structurally or mechanistically similar chemicals for which there is a known toxicity profile to identify hazard traits to less studied chemicals. We extrapolated hazard information from the more studied PPD derivatives to the less studied members of our proposed class. Specifically, we used information from authoritative sources such as US EPA, US FDA, and the Consumer Product Safety Commission, as well as the European Chemicals Agency, also known as ECHA. In addition, we used the US EPA's Hazard Comparison Dashboard hazard module, which aggregates data from various authoritative, screening, and predictive list sources to determine hazard scores for various human health and ecological toxicity endpoints and environmental fate parameters. The hazard comparison dashboard also incorporates US EPA's toxicity estimation software tool, aka TEST, which is a quantitative structure activity relationship or QSAR tool to fill data gaps for some endpoints. Other scientific information, such as data from QSARs, is important in supporting the identification of candidate chemicals. Using this approach, PPD derivatives can reasonably be expected to have either wildlife survival impairment or dermatotoxicity as hazard traits. PPD derivatives have the environmental hazard trait of wildlife survival impairment based on acute aquatic toxicity endpoints. Most studied PPD derivatives are frequently categorized as having very high aquatic toxicity across all trophic levels of the aquatic food chain based on the globally harmonized system, or GHS, of hazard criteria. Our technical document summarizes aquatic information for more studied PPD derivatives provided in registration dossiers submitted to ECHA, as well as toxicological reviews from authoritative sources, such as the Organization for Economic Cooperation and Development, also known as OECD. 1,705 chemicals, or about 92% of our proposed class, have a hazard score for acute aquatic toxicity in the hazard comparison dashboard, with 71% of our proposed class having high or very high scores for aquatic toxicity. In the hazard comparison dashboard, the majority of our proposed class have acute aquatic toxicity hazard scores based on QSAR predictions from the EPA's TEST tool. TEST predicts acute aquatic toxicity based on data from 96-hour fathead minnow or 48-hour Daphnia magna assays. PPD, our parent structure for this proposed class, is recognized by several authoritative bodies as a skin sensitizer and therefore has the toxicological hazard trait of dermatotoxicity. 74 chemicals, or 4% of our proposed class, were scored for skin sensitization in the hazard comparison dashboard, and all were classified with high hazard. Of the 74, 10 or more studied PPD derivatives with high hazard scores based on authoritative lists, such as ECHA's Classification, Labeling, and Packaging CLP list, or screening lists such as Japan's National Institute for Technology and Evaluation NITE classification results. The remainder of the 74 have high sensitization scores based on QSAR estimates from the Ministry of Environment and Food of Denmark. These estimates were used to predict GHS hazard categories for the advisory list for self-classification of dangerous substances. To summarize the information presented today, we'll take another look at the evidence we presented to fulfill the 3 requirements for adding chemicals to SCP's candidate chemicals list. First, we have shown that there are potential exposures to PPD derivatives through various environmental media, including particulate matter, dust, water, and sediment. Second, we have shown there is potential for one or more of these exposures to contribute to or cause adverse impacts, as demonstrated through the identification of hazard traits, in this case, wildlife survival impairment and dermatotoxicity. Lastly, we've summarized how we've used reliable information from governmental reports, peer-reviewed journals, and other scientific information provided through publicly available tools, such as US EPA's Hazard Comparison Dashboard, and considered the extent and quality of that available information to substantiate the existence of the potential exposures and adverse impacts associated with our proposed class of PPD derivatives. For a detailed explanation of our proposal, please see our technical document for the proposal to add PPD derivatives to the candidate chemicals list. We opened our 45-day public comment period on October 2nd, and we're still accepting feedback on our proposal. Please submit comments by Wednesday, November 15th through our CalSafer portal. If you would like to receive updates on our upcoming rulemaking, please sign up to our SCP email list. And for a high-level overview of this proposal, please see our PPD derivative summary document. And lastly, please email us questions or comments at saferconsumerproducts@dtsc.ca.gov. Workshop information, including this recording, will be available on our workshops and upcoming events webpage very soon. SCP just celebrated our 10-year anniversary. Please celebrate with us by visiting our Decade of Safer Consumer Products accomplishments page. And lastly, if you would like to learn more about other DTSC projects, please visit our DTSC Green YouTube channel. SCP is interested in any and all feedback on our proposal, but we are specifically interested in the following questions. First, is our definition of PPD derivatives clear and unambiguous? And second, have we demonstrated in a clear way how PPD derivatives meet the regulatory criteria for designation as a candidate chemical? This is the end of our presentation on PPD derivatives, so now I'm going to hand it back over to Ashley for Q&A.
Thank you, Lynn and Logan. We have now reached the Q&A public comment portion of our workshop. We will do our best to respond to the questions in the order we receive them. As a reminder, we will not be using the chat function. Instead, please click the Q&A button at the bottom of your screen or press *9 to raise your hand if you are joining by phone. When it is your turn, you will be called on to unmute yourself. When you unmute, please state your name and affiliation. You can also send your questions and/or comments to saferconsumerproducts@dtsc.ca.gov, which we have placed in the chat. As a reminder, questions and/or comments submitted to this email will be addressed after the workshop. Please note that a recording of this workshop and the PowerPoint slides will be made available within the next few weeks via the DTSC YouTube channel or the Safer Consumer Products website. Let's begin with the questions. We did have a couple of technical questions that were responded to via written response. So just for recording purposes, I'm going to read them out loud, and then we will have a live answer so that it can be captured in this recording. The first question is, I'm curious about the decision to exclude molecules with the 2, 3, 5, or 6 substitutions on the PPD ring. Why are these excluded?
Good morning, everybody. My name is Topher Buck. I'm one of the senior environmental scientists here in the Safer Consumer Products program, and I've been a part of the 6-PPD and tires, as well as the PPD derivatives teams. And I'll take this question, as Ashley said, we've had 2 basically similar questions, so I'm not going to read the second. It's essentially the same question. You can find the answer to this on page 5 of our technical document. In a nutshell, we excluded PPD derivatives with additional substituents on the phenyl ring because formation of transformation products such as quinones involves oxidation of the phenyl ring, the carbons on that ring, and replacing the hydrogens bound to phenyl ring carbons 2, 3, 5, or 6, those are the unbound carbons in that ring, would potentially block such transformations. The more studied members of this class that demonstrate the greatest toxicity contain no substituents on the PPD phenyl ring, 6-PPD among them, of course, other than the 2 PPD nitrogens. And so that essentially was the basis for our rationale. If you believe that exclusion is unwarranted, and particularly if you have any data to substantiate that belief, we welcome any information that you would like us to consider before we make a decision to propose this new rule. Thank you.
Thank you, Topher. Next question. Regarding the definition of PPD, it was indicated that substitution in the 2, 3, 5, or 6 position makes the material a non-PPD substance by regulation. Does this mean that an organic PPD with a methyl or other group substituted in one of those positions would not be considered a candidate for this regulation?
Yeah, Ashley, sorry, that was, so the short answer is yes. And the answer is essentially the same as the answer I just gave. That was the second question I referred to that's substantially similar to the first, so.
Great, thank you so much, Topher, I appreciate that. So we're going to go ahead and switch to the open questions now. Are there any current publications or studies that examine the toxicological effects of other PPD derivative quinones or other transformation products on aquatic life?
Hi, I'm Mike Garland. I'm a staff toxicologist with DTSC's Human and Ecological Risk Office. Thank you for the question. We are aware of a study out of Hui Ping's lab that evaluated the toxicity of PPD derivative quinones other than 6-PPD quinone. This is something we're looking at. The study has not yet been peer-reviewed, but we are taking a look at it. It looks like of the derivative PPDQs that they looked at, the transformation products did not have that toxicity to coho that 6-PPD quinone had.
Thank you. Next question. What about pro-PPDs, compounds that could potentially form PPD derivatives upon reaction or release to the environment? Would those be considered members of the PPD derivatives class? I could imagine polymerizing PPDs, adding easily removes substituents of 2, 3, 5, 6, or creating functional groups that essentially release or form PPDs upon reaction or oxidation, etc. These types of possibilities might need to be considered in class-based effort.
I'll take that, Ashley. Thank you, Ed, for that question. That may be something we need to discuss with you, with stakeholders in general, and get back to you about. I mean, I think certainly as part of the exercise of crafting a class definition, right, is to sort of define the structural components of chemicals that fall into that class. So I think I can easily imagine that some of the molecules you're talking about may not fit the definition and therefore may not be members of the class. Again, it's in the abstract, I suppose it's a little hard for me to visualize all the possibilities here, but I think that's something that we would be very interested in discussing with you. If you would like to contact us offline, we'll happily talk about that.
Thank you. Just as a reminder to those calling in, if you have a question, if you'd like to raise your hand, you can press *9 and you will be prompted to unmute yourself. Next question. Work by Nair, synthesis and toxicity evaluation of tire rubber derived quinones indicated that there are large differences between the toxicity of quinones from different PPDs. Most are very much less toxic than 6-PPDQ. Can you comment?
Hi, thanks. I'm Kelly Grant. I'm a senior environmental scientist in SEP. And yes, we're very aware of the work by Nair et al. And I think there's even a paper out by folks from Plexus also indicating that I think 7,7-PD quinone has much lower toxicity than 6-PPD quinone. And I just want to remind you that here we're not necessarily just thinking about the quinones, but we're also thinking about the toxicity of the parent compounds, so the PPD derivatives themselves. And so, there is this broader concern for very high acute aquatic toxicity. So we are following those studies, and we are aware that PPD, some of these other PPD derivatives may be much safer than 6-PPD quinone itself. I think Logan mentioned that, the threshold for or I guess I should say that 6-PPD quinone is 10,000 times lower than the threshold for very high acute aquatic toxicity. So we know that there are going to be gradations of toxicity in here. and we are following the science. Thanks.
Thank you, Kelly. Next question. Currently, 6 PPD is being addressed in California and Washington. Do you know if currently it is a concern in other geographies, other countries?
I think I can take that one. In addition to being in safer consumer products, sorry, I'm hearing that I'm getting some feedback, and I apologize. I'm going to lower my volume and see if that helps. Hopefully that alleviates any echo. But in addition to my role here in the Safer Consumer Products Program, I also co-lead the Interstate Technology Regulatory Council team on 6 PPD. And there we've had some interactions with folks in Australia as well as Europe. Certainly, I think it's a concern in those other really continents, but they have yet to take any regulatory action.
Thank you, Kelly. So we're going to go ahead and just give it a few more moments, see if any more questions trickle through the Q&A feature. Once again, for phone callers that are listening in, please press *9 to raise your hand if you have a question and or comment. As another reminder too, if you think of a question and or comment at a later point after this webinar is over, this is just a reminder to go ahead and email saferconsumerproducts@dtsc.ca.gov, and that will be addressed after this webinar. Looks like we have another question in the Q&A feature. Are there any common structures in the formulation of PPD derivatives that differentiate items identified as low, medium versus high/very high?
Hi, this is Lynn Nakayama Wong from SCP again. So we have not done this analysis yet, but we would like to. We just, for the purposes of this proposal, we have not done this evaluation yet, but it's part of our next steps, but not specific to this proposal.
Thank you, Lynn. Just gonna wait a couple more moments to see if any other questions trickle in. Looks like we have another. Could you comment on what a safer alternative would consist of? From a tire industry standpoint, if the PPD class is eliminated, it could delay a solution to the problem.
Thanks. This is Kelly Grant again. So in our alternatives analysis process, it's up to the manufacturers of the priority products, so in this case, tires, to demonstrate that an alternative is safer. So we do not have a definition for safer. That would be something that the manufacturers would demonstrate in their alternatives analysis.
Kelly, I'll just chime in to that under our framework, this proposal would not ban or eliminate the class necessarily. I mean, we would envision that members of the class of PPD derivatives under our definition would be under consideration as potentially safer alternatives. We understand there are always trade-offs. That's where our alternatives analysis process comes in. And as Kelly rightly states, it is the responsibility of the manufacturers of the priority product to do the analysis and demonstrate that it's safer overall.
Thank you. Next question. It was brought to my attention by both Zenu, Tian, and Jennifer McIntyre. 6-PPD and presumably the other PPDs have implications for humans. Tian has found 6-PPD in used crumb tires on synthetic turf playing field. What implications would regulate of PPD class have on use of used tire crumb used in synthetic turf and PIP pour in place playground surfacing?
Hi, everyone. This is Simona Balan. I supervise the External Communications and Environmental Justice in SCP. Thank you, Dan, for this question. So this proposal to list the PPD derivatives class to our organic chemicals list, it really is just that. It doesn't have any implications for the manufacturers of PPD derivatives or anybody who uses these chemicals. However, it does give us the ability, like Logan mentioned, to eventually research consumer products that contain PPD derivatives and decide if it's warranted to list them as priority products. For that, we will need to show that there's potential for exposures to PPD derivatives from the specific product and the potential for significant or widespread adverse impacts associated with that particular use. So given that, we may have the ability to look at certain products like, well, I was going to say synthetic turf, but since this comes from tires, this regulation, or we're already regulating 6-PPD in tires, and PPD derivatives are going to be considered as part of that, as part of the alternatives analysis for 6-PPD in tires. So it's unclear to me if there's going to be a need in the future to look at 6-PPD or PPD derivatives in tires in California, but we would have the opportunity to look at other consumer products that may contain PPD and PPD derivatives and decide if it warrants regulation as a priority product. I hope that answers your question. If not, I'm happy to expand on that.
Thank you, Simona. I'm going to give a few more moments for any other questions to trickle in. Next question. Okay, it was more of a comment, so let me read that aloud. Thank you, Dr. Bland. Recent research has proven 6-PPDs bioaccessibility. Thank you for your comment. Do we have any more questions? Feel free to drop it into the Q&A feature. And just as a reminder, those calling by phone, please press *9 to raise your hand if you have a question and or comment. The next question just came through. DTSC has said that listing PPDs as a class won't prevent these from being adopted as alternatives to 6-PPD in tires if they prove to be safer alternatives to 6-PPD. So what is driving DTSC's motivation here? Are there other products that the agency is considering? I'm a bit confused by the agency's expenditure of resources on this versus identifying other priority products combination.
I don't know if a member of the team wants to take this question. I'll just start. I think the point, one of the points, or one of the rationales for doing this is actually having the alternatives analysis demonstrating the relative safety, because currently the other members of the class are not on our menu of candidate chemicals, and therefore people could potentially switch without being subject to the alternatives analysis requirement. I mean, that's a little bit of an oversimplification of the regulatory situation, but we would just like to see the analysis to make sure people aren't implementing a regrettable substitute.
Let me just add a little higher level response to Tom's question. There's two parts here. One is, we understand how and I know, Tom, you understand how the regulations work. But I want to highlight is that part of the inherent framework of our regulations is the transparency involved in the science and the analysis and the decision making that goes on both by DTSC as the regulator and whomever we regulate in priority products. And so there's value in our minds of putting this information out so that when we're looking at alternatives or a manufacturer is looking at alternatives, that the information on potential alternatives is out there and can be evaluated both in the AA adequately, but also by all the stakeholders and by us. So that's important in general. And in terms of, the motivation for other potential priority products, this is a very iterative process. We only became aware of this issue when the tire issue came up, but we're also now aware that there are other products that use these types of chemicals, and they may be of concern. It takes time to collect information and have the dialogue with all the stakeholders on these issues. And as the information evolves, then we'll address that in our decision making. So we don't just, one day find the information and the next day start regulating. It's a long process. So part of this was highlighted here is that adding this class of chemicals onto the broad menu gives us an opportunity to do more research on, is there a potential area for our action? And there may or may not be, but we don't know until we look. And we can't look until we wouldn't want to look if we don't have the authority to pursue something. So that's the broad rationale for our motivation.
Thank you. The next question is, if a viable alternative that guarantees the safety of 6-PPD in tires is not found throughout this process, what are the next steps? Is 6-PPD maintained?
Maybe if I can unmute myself. Sorry about that. As Logan alluded to, we have a fourth step in our process called regulatory response. And so if during the alternatives analysis, the tire manufacturers cannot find safer alternatives to 6-PPD, that goes into our regulatory response process. And there are two regulatory responses that are automatically imposed when manufacturers do not find a safer chemical, or do not find a safer alternative, I should say. The manufacturers will have to provide information to consumers about the hazard of the chemical in the product. And the second is advancement of green chemistry and engineering. And so that requires the manufacturers invest in research and development of a safer alternative. So hopefully that answers your question. Feel free to follow up if you want more information.
Thank you. Another question just came in. If a viable alternative that guarantees the safety of 6-ppd in tires is not found throughout this process, what are the next steps? Is 6-ppd maintained?
I think that's the one Kelly just answered.
Well, we must have had a duplicate. Thank you.
Ashley, you're muted.
Can you hear me now?
Yes.
Thank you. If you have a question, please drop it in the Q&A feature. If you're calling by phone and have a question, please press *9 to raise your hand. We'll just wait a couple more moments. Looks like they're trickling in. We'll just give it about one more moment, just in case anyone thinks of something. And just as a reminder, if you do think of a question and or comment after the conclusion of this webinar, you can go ahead and just send it to saferconsumerproducts@dtsc.ca.gov.
It looks like there's a hand up.
We actually have a question that just popped in. In the priority product identification document, DTSC listed a number of alternatives to 6-ppd, some of which were PPD related. Do any of those fall outside of the proposed PPD definition?
That's a very good question, Tom. I have to admit, off the top of my head, I don't know the answer to that. We could certainly get back to you about that. It is a good question.
Thank you so much. So it looks like we do have a raised hand. Joseph Draper, I'm going to allow you to speak, so go ahead and unmute yourself when you are ready.
Great, thank you. Yeah, so my name is Joseph Draper with the California Stormwater Quality Association, also known as CASQA. So this is really just a comment. I don't have a response to your questions here, but CASQA is dedicated to advancing sustainable stormwater management, protective of California's water resources. And in 2020, we adopted a vision for sustainable stormwater management. And one of the focus areas are focusing on true source control solutions, which is eliminating pollutants from the source. And this is because stormwater serves as an important transport medium for pollutants like PPD and its derivatives, carrying them from our environment and into our water systems. And so I just want to say that CASQA strongly supports DTSC's proposal here to add PPD derivatives to the candidate chemicals list, as it will help ensure replacements of 6-ppd are not replaced with similar chemicals of similar aquatic toxicity. So thank you.
Thank you very much. Do we have any questions and or comments? Just as a reminder, if you're calling by phone, please press *9 to raise your hand. We're going to allow one more moment just in case there's any last minute questions and or comments. And then we're going to go ahead and wrap up today. All right, it looks like those are all of the questions and our comments for this webinar. This concludes our Q&A session as well as our presentation today. Thank you for your interest and your participation. I will hand it over to Carl for closing remarks.
Thank you, Ashley. Well, first, thank you everyone for being here and engaging with us on this issue. It's really important to us that we get your perspective and input, feedback on our proposal. And so thank you for today, and thank you in advance for submitting comments in writing, which is really helpful to us too. And just a reminder that we'd like to get those comments in writing by November 15th, and you can go to our CalSafer site and submit those, as well as see other folks' comments as well. So yeah, and I want to thank our staff, particularly our presenters, Lynn and Logan, and Andre and Ashley for helping us navigate this workshop today. And as you can see, we've spent a fair amount of time and energy in looking at this issue, and we really value your input and will benefit it in the long run. And I just want to make a comment just to go back to Logan's early slide about our process and just remind folks that where we're at in the process now and what the journey looks like. A lot of the questions today were really good questions. Some of them were probably more appropriate to the alternatives analysis phase of our work. And those are really good questions. So I encourage you to stay tuned to participate that in particularly in our where we're going in the near term with tires containing 6-PPD. And just a reminder that most of the stages of our process are it's very important. Transparency is important about how we make decisions, what we're evaluating. We really need your input in that process so that we can make smart decisions. And also a reminder that our process has a lot of checks and balances as we go. So here we're talking today about, adding a menu of chemicals onto our candidate chemical list. That doesn't do much inherently at the beginning, but it might come into play later on as we decide which product we might want to look at to contain those chemicals. It's relevant to the AA process. And also, I just want to remind folks that, Howard's question about, really what does safer look like is one we get oftentimes. And I just want to remind folks that our framework is very different than most ones we're used to, is that DTSC is not setting a threshold under which we say something is safe, over which we say something is not. That's not how our construct works. And so that burden shifts to the manufacturers in our AA process to do a lot of the analysis and to make a determination of what they think is safer or not and why. And then there are checks and balances allowing the public to comment and all stakeholders. And then ultimately, DTSC makes decisions about the adequacy of the AA and if there's any further work that needs to go on after that. So some of these questions are certainly yet to be raised and certainly yet to be answered. And so I just want to encourage you to stay with us throughout that process. It's really important that we get good outcomes for everyone. So with that, again, I thank you all for being here today, and I'm thanking you for your continued engagement. If you have questions as this ferments, or you get a chance to read the background document, please let us know, and we'll look forward to moving forward from here. So thank you very much. And with that, we'll just conclude the workshop.
Thank you very much, everyone. Have a great day. Thank you once again for your time and your participation.